You know that very specific type of frustration?
Yeah.
You're at a dinner party and you're talking to someone about, I don't know, some historical event,
I think I know where you're going with this.
and they're just so loud, so articulate, citing these like specific dates and names with this unshakable conviction. And you start to shrink a little bit in your chair thinking, wow, okay, I must be completely misremembering this.
It's the confident hallucination. It's a very human trait, but unfortunately, we have managed to export it perfectly to our AI models.
We really have. We've all had that moment with ChatGPT or Gemini or whatever model you're using.
Yeah.
You ask a kind of niche question, and it gives you this beautiful, grammatically perfect, structurally sound answer.
Oh, it's beautiful. It's fluent. It sounds like it was written by a professor.
Exactly. It cites a source, it gives a date,
Hmm.
and then you check, and the source doesn't exist, and the date is from, like, a different century.
Right. And for a long time, the industry's answer to that problem, the hallucination problem, has been something called a RAG.
Retrieval Augmented Generation.
Wow.
Which, to put it simply for everyone, is like giving the AI an open book test. Instead of relying on its own kind of fuzzy, dreamlike memory from its training data,
Right.
it goes and looks up documents, reads them, and then answers your question. It's supposed to ground it in facts.
In theory, yes. It retrieves relevant information and uses that to generate the answer. It's meant to be the truth anchor. It grounds the creative writing capability of the LLM in hard facts retrieved from a database.
But here's the hook for today's deep dive, and it's something I don't think we talk about enough. We treat RAG like it's this magic wand that just fixes everything.
You do?
But what happens when the AI grabs the wrong book from the shelf? Or what happens if the AI just thinks the book is relevant because it shares a few key words, but it actually has nothing to do with the question you asked?
That is the critical failure point. In standard RAG, the generator, that's the part that's actually writing the answer, it usually has blind faith in whatever the retriever component hands it.
Blind faith.
Totally. So if the retriever hands over garbage, the generator produces a very polished, very convincing piece of garbage.
So the open book test analogy completely fails if the student grabs a comic book instead of the history textbook and just starts treating it as fact.
Precisely. So today we are unpacking a methodology that tries to fix this specific architectural flaw. It's called CRAG, that's C-R-A-G, for Corrective Retrieval Augmented Generation. And that corrective part is really doing a lot of heavy lifting here.
We're looking at a paper titled Corrective Retrieval Augmented Generation by researchers from USTC, UCLA, and Google DeepMind. And the mission today is to understand how you build an AI system that doesn't just look things up, but actually judges whether what it found is any good, and then, and this is the key part, fixes itself if it's not.
It's essentially attempting to give the AI a sense of self-doubt, or at least a sense of editorial oversight, you know?
Which I love. I think we could all use a little more healthy self-doubt in our lives.
Yeah.
But before we get into the solution, the whole CRAG methodology, I want to really nail down the problem. Because I think a lot of people assume RAG is a solved game.
Oh, for sure.
You have your vector database, you do a cosine similarity search, you get your context, you pass it to the LLM, done. Why isn't it that simple?
Well, it sounds simple when you pitch it at a conference, but let's look at the standard workflow under a microscope for a second. You ask a question. The retriever component scans your database. But you have to remember the retriever isn't usually reading the documents in the way you or I do.
It's not comprehending it.
Not at all. It's looking for mathematical similarities in embeddings or sometimes just simple keyword overlaps. It's a pattern matcher.
So it sees the shape of the words, but not the soul of the sentence.
That's a poetic way to put it, but yeah, that's pretty much it. And the connection between that retriever and the generator is usually seamless.
Seamless sounds good, though. In consumer tech, we always want seamless. It's the goal.
In user interfaces, yes, absolutely. But in information architecture, seamless often means uncritical. The generator just assumes the retriever did its job perfectly. The paper gives this fantastic example of this failure in action.
Okay, let's hear it.
Imagine you ask the system a very specific question. Who was the screenwriter for Death of a Batman?
Okay, very specific. Death of a Batman. Not the death of Batman or just Batman, but Death of a Batman. I'm assuming this is some obscure comic or maybe a novelization.
Exactly. It's a specific, less popular entity. Now, a standard retriever looks at that query. It sees the keywords Batman and screenwriter.
Oh, okay.
It kind of ignores the nuance of that specific title, Death of a Batman. It dives into the database, and what do you think it pulls up?
It pulls up the Tim Burton movie. The 1989 Batman film,
You got it. It pulls up the Wikipedia page for the 1989 Batman film.
which was famously written by Sam Hamm.
Right. So the retriever hands this document about the 1989 movie to the generator. The generator reads it, sees screenwriter Sam Hamm, and thinks, aha, I've got it. I have the answer. So it confidently answers. The screenwriter for Death of a Batman is Sam Hamm.
But that's objectively, demonstrably wrong. It answered a question I didn't ask because the retriever got distracted by the shiny Batman keyword.
It's completely wrong, but think about it from the user's perspective. The user sees a confident answer, probably with the citation to a real document. The seamless nature of the system completely hid the error.
And most users aren't going to click that citation and read the whole source document to verify. They trust the summary.
Exactly. The generator didn't stop to say, wait a minute, this document is about the Tim Burton movie, but the user asked about Death of a Batman. These aren't the same thing. It doesn't have that critical thinking step.
That is the blind faith problem. The generator is just an improv artist trying to make the prompt work with whatever props it's been handed. It's yes-anding its way to a lie.
Yes, indicating to a lie is the perfect description of standard ARG hallucinations. And this is where CRAG comes in. The researchers wanted to break that seamless coupling. They wanted to introduce a quality control inspector right between the retrieval and the generation.
Enter the Retrieval Evaluator. This is the core new character in our story today.
It is. Think of the Retrieval Evaluator as a very strict editor, or maybe a teacher grading the retriever's homework before the star student. The big LLM gets to see it.
It's a gatekeeper.
A gatekeeper, a bouncer, an editor. Before the massive, expensive language model gets to rate the answer, this evaluator looks at the retrieved documents and asks a hard question. Is this actually relevant? Does this actually answer the specific question the user asks?
Now, I was looking at the architecture diagram in the paper, and what really surprised me is that they don't use a massive brain for this.
Yeah.
They aren't using GPT-4 or Gemini Ultra to check the work. I would have thought you'd want the smartest possible model to be the judge.
Right. That's the common intuition, isn't it? Use the biggest brain to check the work of the other components. But the researchers made a very specific and I think very clever counterintuitive design choice here. They use what they call a lightweight model. Specifically, they fine-tuned a model called T5 large.
T5 large. Okay, for the non-engineers listening, that sounds big. Large is in the name, but in the world of modern LLMs, that's actually tiny, isn't it?
It's microscopic by today's standards. T5 large has about 0.77 billion parameters. Just for context, compare that to GPT-4, which is rumored to be in the trillions, or even open source models like LaMDA3, which are in the 70 billion parameter range.
Wow.
We are talking about a model that is roughly 1/100th the size of the models we usually talk about on these deep dives.
So why? Why use the little guy for such a critical job? If the goal is accuracy and we're trying to fix the mistakes of a smart system, why are we trusting a, for lack of a better word, dumber model to do the grading?
This touches on a really fundamental misunderstanding a lot of people have about AI size versus capability. It's not just about being smart or dumb in a general sense. It's about being general versus specialized.
Okay, break that down for me.
A model like GPT-4 is a generative model. It's designed to continue text, to be chatty, to be creative, to find connections between things. If you ask it a question like, is this document relevant? It might actually overthink it. It might say, well, in a metaphorical sense, yes. Or it might hallucinate a connection that isn't really there because it's fundamentally trained to be helpful and to generate text. It wants to find a way for the answer to be yes.
It's a people pleaser. It doesn't want to be difficult.
It's a total people pleaser.
Yeah.
T5 in this implementation is fine-tuned for a discriminative task. It's not a generative task. It doesn't need to write poetry. It doesn't need to code in Python. It has one single job.
What's that?
Look at the question, which we can call X, and the document, and output a score. Relevant or not relevant. That's it. Yes or no.
It's a bouncer at a club. It doesn't need to know how to dance or make conversation. It just needs to know who is on the list and who isn't.
That's a fantastic analogy. And because it's been intensely fine-tuned on that specific binary task, it can actually outperform the giant generalist models at that one job. It's not distracted by the generative urge to make things up or be helpful.
I definitely want to get to the performance numbers on that later because they are pretty shocking. But let's stick to the flow for now.
Yeah.
So we have this T5 bouncer the evaluator. The documents come in from the database. The evaluator looks at them, and it assigns a confidence score.
Right.
Based on that score, it triggers one of three actions. This is really the heart of the CRAG methodology, isn't it? This decision tree.
This is the core logic. Everything flows from this one decision.
So what are the three paths?
The paths are correct, incorrect, and ambiguous.
Okay. Good, bad, and maybe. It sounds simple enough, but I have a feeling the execution is where all the complexity lies.
Yeah.
Let's start with a happy path. Action path 1, the evaluator looks at the documents and says, score is high. These look correct.
Right. The confidence score is above a certain upper threshold. The system believes it has found the right information in its local database.
So does it just hand the documents over to the generator and say, go for it? Because that's what standard doc does. If the doc is good, use it.
No, and this is another one of those places where CRAG really diverges from the pack.
Yeah.
It has this core insight that even when a document is correct, it's rarely perfect.
What do you mean by that? If it has the answer, why isn't it perfect?
Well, let's use an analogy. Imagine you ask, what is the capital of France? And the retriever, doing a pretty good job, pulls up a 5,000-word history of Europe. The answer, Paris, is definitely in there. Absolutely.
Right, so it's a correct document.
It's correct, but it's also incredibly noisy. There's information about the Roman Empire, World War II, French wine production, the Tour de France, and macroeconomic trends of the 1990s.
And we know that LLMs can get distracted. If you feed that whole 5,000-word document into the generator's context window, you're just diluting the signal. You're making it harder for the model to find the answer.
Exactly. You're forcing the generator to sift through a giant haystack to find one tiny needle. And there is a very real cognitive phenomenon in LLMs called lost in the middle.
Lost in the middle. I've heard this term floating around. This is the idea that LLMs basically only pay attention to the beginning and the end of a long prompt.
Essentially, yes. If you give an LLM a massive block of text as context, its attention mechanism tends to focus heavily on the first few paragraphs and the last few paragraphs. The crucial information buried in the middle often gets ignored or hallucinated over.
It's like a student skimming a reading assignment. They read the intro, they read the conclusion, and they just pray the exam doesn't ask about chapter 3.
I feel seen. And CRAG is specifically designed to solve this lost in the middle problem. Even in the correct scenario, it doesn't just pass the document along. It uses a process called knowledge refinement.
Knowledge refinement.
And the algorithm they use for it is called decompose, then recompose.
Decompose and recompose. Okay, that sounds like something from a sci-fi movie. Let's break it down step by step. What is step 1? Decomposition.
The system takes that retrieved document, our 5,000-word history of Europe, and it chops it up into little pieces. They call them knowledge strips.
Strips. So it's like running the document through a paper shredder.
Sort of, but a very smart, deliberate shredder. If the document is short, maybe just 1 or 2 sentences, the whole thing is treated as one strip. But if it's a long article, they split it into smaller units, maybe a few sentences each. The goal is to granularize the information into these little bite-sized chunks.
Okay, so we're taking the long history of Europe and cutting it up into these little slips of paper, each with a couple sentences on it. Why go through all that trouble?
Because it completely flattens the information hierarchy. By decomposing the document into these independent strips, CRAG forces the system to evaluate every single sentence on its own. It removes the middle because now everything is its own isolated unit. There is no middle to get lost in.
Ah, I see. So it doesn't matter if the sentence about Paris being the capital was on page 1 or page 50. Once it's a strip, it's just a strip standing on its own.
Exactly right. And that brings us to step 2, filtering. The Retrieval Evaluator, that same strict T5 editor we met earlier, comes back into the room.
The bouncer is back.
The bouncer is back, and it looks at each individual strip and scores it again. Is this specific sentence relevant to the user's question, what is the capital of France?
So it's basically taking a digital highlighter to the text. It's saying, this paragraph about the Roman Empire, irrelevant, score 0, trash it. This sentence here about Paris being the capital, score 1, keep it.
Precisely. It's filtering out all of the noise at a very fine-grained level. And then you have step 3, recomposition. It takes only the high-scoring strips, the highlighted sentences, and it stitches them back together.
So what you're left with is not a 5,000-word article, but maybe just 1 or 2 sentences. A super concentrated dose of pure information.
Pure signal, 0 noise. The generator then receives this refined chunk of internal knowledge, and because all the distractions are gone, the lost in the middle problem completely disappears. The LLM doesn't have to search for the answer. The answer is the only thing it's reading.
I love that. It's the difference between giving a student a whole textbook and saying the answer is in there somewhere versus giving them a single index card with the exact paragraph they need to read.
That's a perfect comparison. And it has other benefits too. It saves processing power for the generator because it has less text to process, which means lower latency and lower cost. It's efficient and it's accurate.
Okay, so that's the happy path. The documents were good, and we made them even better by refining them. But let's go to the dark side. Action path 2, the incorrect scenario.
Right. This is where standard ARG completely falls apart, but it's where CRAG really, really shines. So the evaluator looks at the retrieved documents, and the confidence score is below the lower threshold. It says, these are all garbage.
In a normal system, this is the exact moment the hallucination happens.
Yeah.
The system would just try to wing it, or it would take the garbage documents and present them as fact anyway, because it has nothing else to go on.
Correct. Standard RAG is an optimist. It assumes that if it retrieves something, it must be useful. CRAG is a realist. It acknowledges that sometimes your database just doesn't have the answer.
It's okay to say, I don't know.
It's not just, okay, it's a critical feature. So what does it do when it hits that wall? If the internal documents are rejected, CRAG admits defeat regarding its own internal database, and it triggers a web search.
It goes to the live internet. It Googles it.
Basically, yeah, it uses a commercial API like Google Search or Bing. But here's the catch, and this is a technical nuance that really matters for performance. You can't just paste the user's question directly into a search engine and hope for the best.
Why not? I type questions into Google all the time. Who is the screenwriter for Death of a Batman? Seems like a perfectly fine search query.
It might work for that specific one, but LLM prompts can be really weird and conversational. They might be something like, hey, can you please tell me about the socioeconomic impact of the 2008 financial crash, and then compare it to the Great Depression of 1929?
Right, or write a poem about.
Exactly. Search engines really struggle with that. They prefer keywords. They want socioeconomic impact 2008 versus 1929 statistics. They want entities, not prose.
That's true. If I talk to Google like I talk to ChatGPT, rambling, full of context, I usually get pretty bad results. I get a bunch of blog posts instead of data.
Precisely. So CRAG includes a component that they call the query rewriter.
This another model? Another T5 bouncer?
It can be. Usually it's just a specific prompt sent to a model like ChatGPT, or even a smaller local model. Its only job is to take the user's natural language input and translate it into search engine-friendly keywords.
Do they have an example in the paper?
They do. The user's question was, what represents the 2004 Legg Mason Tennis Classic?
Which is a bit of clunky phrasing, honestly. What represents could mean a lot of things.
Right. If you plug that directly into Google, you might get articles about symbolic representations or metaphors. So the rewriter changes it to something much simpler. 2004 Legg Mason Tennis Classic, sport.
Simple. Direct. It strips out all the ambiguous grammar and just leaves the core entities.
And that query is much, much more likely to get a direct hit on Wikipedia or a dedicated sports database.
So it rewrites the query, it searches the web, it gets back a bunch of URLs. And then what? Does it just start reading the whole internet?
No, it has to be very selective. The paper specifically mentions prioritizing authoritative pages. In their experiments, they heavily favored Wikipedia to avoid falling into traps like random blog rumors or biased web content. This is a crucial step because the web is full of misinformation.
That's a really important point to emphasize. If it just scraped Reddit or Twitter, we'd be right back to the garbage in problem, just on a much, much larger scale.
It would be catastrophic. So it scrapes the content from those high-quality URLs, and I bet you can guess what it does next.
Don't tell me. It does the script thing again, doesn't it?
It does the strip thing again. It applies the exact same knowledge refinement process, decompose, filter, recompose, to the data it just scraped from the web.
That makes perfect sense. Just because a fact comes from a Wikipedia page doesn't mean the entire page is relevant to my question.
Right. If I ask about the population of a specific city and it pulls the Wikipedia page for that city, I don't need the entire history of the mayoral elections in 1950. I just need the demographic section. So the evaluator strips out the noise and keeps only the signal.
The logic here is so consistent and so, I guess, humble. It's admitting that its own memory, its database, failed. So it looks up live information, but it still treats that new live information with the same level of skepticism and refines it before it's willing to use it.
It creates a dynamic knowledge base on the fly to replace the static one that failed it. It's adaptive in a way that standard RAG just isn't.
Okay, so we have correct, where we use the database but clean it up first. And we have incorrect, where we use the web and clean that up. But you mentioned the third path, ambiguous.
Yes, because life is rarely black and white, right? Sometimes the evaluator looks at the retrieved documents and says, I'm not sure. The confidence score is stuck right there in the middle, between the upper and lower thresholds.
The ambiguous scenario. This feels like the most dangerous place for an AI to be. If you're not sure, you could easily make a big mistake by throwing away good information, or conversely, by keeping bad information.
Which is exactly why the methodology for this path is based on the idea of robustness through redundancy. In the ambiguous path, the system does both.
Both. What do you mean both? It uses the database and the web.
Exactly. It processes the internal documents, refining them, stripping them down, trying to find any good bits that might be in there. But it also triggers the web search to go find external context at the same time.
A belt-and suspenders approach.
That's the idea. It doesn't want to risk throwing away the internal data in case it was right, but it also doesn't want to rely on it solely in case it was wrong. So it gathers information from both sources, refines them both into strips, and then it hands the whole combined package to the generator.
So it's basically saying to the big LLM, look, here's what I found in my notes and here's what I found on Google. They might agree, they might not. You're the smart one, you figure it out.
Pretty much. And ideally, the generator can then synthesize a much better answer by seeing where the two sources agree, or by using the web data to contextualize the ambiguous internal data. It creates a safety net for those tricky situations where that lightweight evaluator is confused.
It's really designing for failure, isn't it? The whole architecture. It assumes the retriever will fail. It assumes the evaluator might be confused. It assumes the documents themselves will be noisy. It's a very pessimistic or maybe realistic way to build a system.
Realistic is absolutely the right word. Standard RAG is optimistic. It assumes every step in the chain works perfectly. CRAG assumes every step is messy, imperfect, and prone to error. It builds the safety rails, assuming the train will try to go off the tracks at some point.
I want to circle back to that lightweight evaluator we talked about at the start. You said they use T5 large, and you said that CRAG itself is a plug-and-play wrapper. This feels like a huge deal for developers or companies that are actually trying to build these things in the real world.
It is a massive selling point. You have to understand, retraining a large language model is incredibly difficult and expensive. If you want to fix hallucinations by making the brain itself smarter, which is an approach called self-RAG, you're talking about millions of dollars and months of training time.
Right. You have to teach the model new critic tokens. You have to change its fundamental weights. That's brain surgery.
CRAG isn't brain surgery. It's like putting on a pair of glasses. You don't touch the generator at all. You can use Llama, you can use ChatGPT, you can use whatever proprietary model you have. CRAG is just a wrapper that you put around it. It manages the input before the big model ever sees it. It's middleware.
So if I'm a company with a customer service chatbot that keeps lying to customers, I don't have to throw the whole thing away and start over. I can just bolt CRAG onto the front of it.
In theory, yes. You add the evaluator and the web search loop. And the paper makes a very specific claim about that evaluator's performance that I alluded to earlier, which makes this even more compelling. They tested it head-to-head against ChatGPT.
In the specific task of judging document relevance.
Yes, exactly that task. They took a data set of questions and documents and asked both models the same simple question. Is this document relevant to this question? Yes or no?
Now, my intuition, and I think most people's intuition, says ChatGPT wins that contest easily. It's the smarter, larger, more expensive, more capable model.
You would absolutely think so. But in their experiments, the little T5 model, because it was fine-tuned specifically for this one discriminative task, outperformed ChatGPT by a huge margin.
Really? Okay, give me the numbers.
The fine-tuned T5 model had an accuracy of 84.3% in judging relevance.
Okay, that's pretty good. B+. What did ChatGPT get?
ChatGPT only managed 58%.
Whoa! Stop there. 58%.
Yeah.
That is barely better than flipping a coin. A coin flip is 50%.
It is shockingly low for such a powerful and well-regarded model. It really stopped me in my tracks when I read that.
Why was ChatGPT so bad at it? What's the theory?
Well, it goes back to what we were saying earlier, the curse of the generalist. ChatGPT is trying to be conversational. It's trying to be helpful. It looks for any possible connection. It hallucinates relevance where there is none.
So if the document mentions Batman, and the question is about death of a Batman, ChatGPT might say, yes, this is relevant because they share the general topic of Batman.
Exactly. Whereas the T5 model, which has been trained on hard negatives examples where things are very explicitly not relevant, it says, no, these are two different entities, not relevant.
It's the difference between a golden retriever who loves everyone who comes to the door and a trained security guard who is just checking IDs. The golden retriever is smarter in many general ways. but you don't want him guarding the door.
That's a huge takeaway for anyone listening who works in this space. Bigger isn't always better. A small, specialized tool often beats the giant Swiss Army knife, and it's also faster and much, much cheaper to run.
So we've got this system. It judges the docs. It searches the web if it needs to. It refines everything. But does it actually work when things go really wrong? Did they stress test it?
They did. They performed what they call robustness tests, and they did something really mean to the AIs to see how they would react.
I love mean AI experiments. What do they do?
They deliberately polluted the database. For a given question, they took the correct answers out, and they replaced them with documents that were irrelevant or just flat out wrong. They essentially gaslit the AI. They forced it into a situation where the correct path was impossible using only its internal data.
They sabotaged the library to see if the librarian would notice?
Exactly. And as you'd expect, the performance of the standard RAG system tanked immediately. It just read the bad documents and lied to the user with confidence. It had no mechanism to doubt what it was seeing in its own library.
Because it has that blind faith we talked about.
It has blind faith, but CRAG maintained its performance almost perfectly.
Because it looked at the bad documents, the evaluator said, "This is trash," and it immediately triggered the web search to find the real answer.
Precisely. It recognized the sabotage and it bypassed it completely. That is the very definition of a robust system. It's not just about being smart when things go right. It's about not crashing and burning when things go wrong.
That's fascinating. It really changes the role of the AI in my mind. It stops being just a writer, and it starts being more of a researcher or an editor.
That's the shift. We are moving from building smart writers to building smart editors.
I want to step back and look at the bigger picture here for a minute. We've been talking a lot about the methodology, the evaluator, the strips, the web search. But what does this mean for the future of how these systems are built and how we think about knowledge?
Well, think about the core assumption that CRAG makes. It assumes that if the internal static database is wrong, the live dynamic internet is right.
Which is a pretty bold assumption to make these days.
It is. It relies on the dynamic nature of the web to fix the static limitations of a curated database.
Yeah.
But it also implies that our static databases are becoming less and less important over time.
That's true. If the AI can just go Google it and get a better, more up-to-date answer, why am I spending millions of dollars maintaining a perfectly curated, indexed vector database of the world's knowledge from last year?
You still absolutely need it for proprietary data, your company emails, your specific product manuals, things that aren't on the public web. But for general knowledge, CRAG suggests that maintaining a static copy of the world is a losing battle. The world changes too fast.
So the correct action path might become less common over time, and the incorrect path, the one that triggers a web search, might actually become the default for a lot of queries.
I think that's a very likely future. The AI becomes, in a way, a very sophisticated search engine wrapper that reads, evaluates, and summarizes the results for you. But there's a massive risk there, too.
What's the risk?
If the web itself becomes flooded with AI-generated content,
Oh no, I see exactly where you're going with this.
and your CRAG system relies on the web to fix its own hallucinations.
It's an Ouroboros, a snake eating its own tail. The AI is fact-checking itself with facts generated by other AIs.
If the web search pulls up an article written by another hallucinating AI, the CRAG evaluator might look at it, see that it's fluent and well-structured, evaluate it as correct, and then we're right back to square one. But now the hallucination has been laundered through the web.
That is a genuinely terrifying thought. The feedback loop of AI correcting AI with AI-generated content, with no human in the loop.
Which is why that one little detail in the paper, that the evaluator component needs to be trained not just on relevance, but potentially on truthfulness or source credibility, is so critical. In the paper, they prioritize Wikipedia for this exact reason. It's a human-curated anchor in a sea of algorithmic noise.
So as long as we have Wikipedia or other verified human-edited sources, we have a fighting chance.
Let's hope so, because if we lose those anchors, the whole system could drift.
I want to touch on one more detail from the paper that we skipped over, the comparison to self-RAG. You mentioned it briefly as the brain surgery option, but conceptually, how does it differ from CRAG?
Self-RAG is a really fascinating parallel approach to the same problem. It attempts to do all the critique and correction inside the generator model itself. The model essentially talks to itself.
How does that work?
It generates a sentence, and then it generates a special token that essentially says, wait a minute, is this true? Or, is this supported by the evidence I have? Then it reflects on that and generates the next sentence.
So it's introspective. It's checking its own work as it goes along, sentence by sentence.
Exactly. CRAG is extrospective. It doesn't ask the model to think about itself. It relies on external tools, the evaluator, the web search API to do the checking. And if you look at the history of computing, it usually favors modular external tools over monolithic complex systems.
It's easier to upgrade one module than to retrain the entire brain.
That's my bet. If a better retriever comes out next year, with CRAG, you just swap it in. If Google search gets worse and you want to switch to a specialized scientific search engine, you just change the API key. You aren't locked into a specific trained model behavior that's hard to change. It's more flexible.
So CRAG is the modular, practical, engineering-focused future.
That's my take on it, yes.
Well, if we were to sum up the entire CRAG methodology, it's really a system that admits when it's wrong and, more importantly, knows how to ask for help. It's honestly a pretty good life lesson.
It is. The smartest person in the room isn't the one who knows everything. It's the one who knows how to look up what they don't know and how to filter out the nonsense they find.
Absolutely. Okay, so as we wrap up this deep dive, I want to leave the listeners with a final thought to chew on. We talked about how this represents a shift from static databases to live web search. If that trend continues, and we have autonomous agents built on systems like CRAG that are constantly verifying and discarding their own internal data in favor of the live web, do we eventually reach a point where the training of an AI doesn't matter as much as its retrieval logic?
That's the provocative question, isn't it? Right now, we're all obsessed with who has the best foundation model. Is it GPT-4 or Claude 3 or Gemini 1.5? But methods like CRAG suggest that maybe a smaller, dumber model with a brilliant retrieval and correction architecture might actually beat the genius model that can't look things up or question itself.
It's the genius locked in a library with no new books versus the average person with a smartphone and a healthy dose of skepticism.
Exactly. And in the real world, the average person with the smartphone and the ability to fact-check themselves wins every single time.
I think that's the perfect place to leave it. The future might not be about building bigger brains, but about building better fact-checkers.
I bet on it.
Thanks for diving deep with us today. Let us know what you think. Would you trust an AI that admits it's confused, or do you prefer the illusion of the confident hallucination?
I will take the honest confusion any day of the week.
Same here. We'll catch you on the next deep dive.